something more like direct. Yeah, a little easier. Just a little easier. Let's see. Let's try. Let's try.
Are you gonna do one with this cubic?
I'll actually start you like with even if it. You want which one do you want to do? Do you want to start a little easier and do like quadratic first?
Sure. Quadratic means x squared, right?
Yes.
Yeah, sure.
So we'll start you with this. Now I know these can be factored anyway, but that's not the purpose of this lecture. The purpose is to like this can be used on any high level polynomial, but we start easy, right? So take your guesses. What's your last term? It's in.
Yeah, it's a yeah.
Yeah.
My last term was an 8, so it's really 1, 2, 4, and 8.
Good job. And it could be plus or minus. Now, you've got a bunch of positive. That should give us a clue, right? Pretty easy. So what's your root? Your root would have to be non-positive if these look to be positive, don't they?
Yeah.
That's a clue. That doesn't always happen. You don't always guess it's but this is pretty easy because your factors are both positive. If the monomials are positive, then the roots need to be negative, correct?
Mm-hmm.
So guess one. What one of these numbers? You might even use your knowledge in factoring to kind of see what one of these might be.
I would say. I want to do 2, but.
So you want to do 2. That sounds right, but not positive though, because the monomials probably need to be positive in their factored form. So the root's got to be -2, right?
Yeah.
Which means that the factor monomial, I hope you're getting this, has to be the opposite in sign. Because we know that if we plug that into the polynomial, that's going to give us a 0, which is what we're trying to do. We're trying to find the factored form. In order to do that, you have to search for the 0 first. You have to approach this logically, right? And then you put it in monomial form. So what does your fraction look like? You've got this, right? Write it out nice and steady. Nice and steady. And then what goes down here is what?
X plus 2.
Very good. Now what I like to do is I like to keep this over to the left and I put the division algorithm to the right, right? Let's put it there. All right, let's do it. Put my minus there. You always stop at the second term, by the way, just like in division, right?
Yeah, so it's going to be X.
Good. That's the first.
And yeah.
It can't be any higher, right? Because if it was higher, you wouldn't have started with a squared. We need that to be an x squared, because x times, yeah, you see what I'm saying?
Yeah.
Okay, now we can't just leave it there. We got another number. Can't leave that out.
Yeah, so it's going to be 2X.
Good. You're doing very good, by the way. So now we know this is always 0 because it's trivial to write it there. You know why? Because you were trying to get an x squared to begin with, right? It's often useful to start out that way. It's useful to say, okay, I need this to cancel, and I know my minus is there to begin with because that's part of the algorithm. So that means I need this I'm going to put my x squared there, and then I make a guess of what that needs to be to make that happen. You see what I'm saying? And then you finish the job on the other one. That's the extra piece right there. That's the extra piece right there. That is the extra piece right there. You see what I'm saying? We already know that has to be an x to give us x squared. That's the easy part. What we pick up is that 2x. Does that make sense? Now what's your answer over here, down beneath it?
4X.
Good. Thank you for not saying 0, because we already knew that. That's why we put that there. And then you do what over here? You do what? You drop or die, Cage. What do we do with that?
bring down the positive 8.
Very good. And then we put what here? What goes right here? And what goes right here?
You put a 4.
Well, no, I want you to get the algorithm. What symbols do I put there? What goes in that box there?
Subtract.
Very good. Very good.
And then you put a 4.
A 4x, right? So in order for that to be a 4x, what's my guess got to be up here?
Plus 4.
4. Good. Dude, you're getting it.
You know why?
Why?
Because as soon as you put the subtraction sign there, and I know that they have to cancel out because our goal is to get 0 at the end to make sure that
Very good.
that we have the right, that we factored it right. And if I
Right.
put a negative 4 there, it would have become 4 minus a negative 4. And that would
Yes.
have given us a positive. So we
Yes.
do not want that.
That's right. Very good.
So that's why I did positive 4.
Mess around
So
with
when you-
Sage and find
yeah.
out, my guy. Good job.
And if you look, guess what? 4 times 2 is 8. So if you look, and it equals 0.
0. Very good. So we factored it. Guess what we just got? What's our answer? What's one of? So the beautiful thing about this is you pick up the other factor. You only need to guess one. You don't have to do any method to get. So then that means that your factor
Times
form.
x plus 2. X plus 2 times x plus 4. Yeah.
See, you're amazing. You did it.
Let's do another one.
Very good. Let's try. Yes. You're very fast at picking this up, eh? I'm pretty sure the audience is like, that guy, that kid is keeping up with him. How is this possible?
I'm a very slow one, trust me.
You are learning this for the first time. I know. I am too, but, you know, I'll be daggone. You're doing it. Alright, now what do we do?
Well, let's find the factors. So your 1 is the factors of 1. So for 4, you have 1, 2, and 4.
Okay.
Let's find the factors. So so for 4, you have 1, 2, and 4. Plus or negative 4. And for plus or negative 1, it's just 1.
Very good.
Now if you were to ask me, I would say 4.
Yeah.
And and both of them are positive, so it should give me a clue that our answer is going to be plus.
Right, that
X
means
plus
that the
4.
root is -4, but the factored form we need is x plus 4. Yeah. When you do your
Yeah.
guesses, because we call this the rational root, we can't have a root form in the division. We have to put it in it's the only way to do it right. Now let's do our algorithm.
I noticed that plus 4, the problem may have written plus 4, but the root is always going to be the negative. But in the end, we are going to write x plus 4 as our guess.
This is correct, yeah, and it's good you see that. Yeah. The reason I say to start like
Okay,
this is
so-
because there's another algorithm I'll teach you called synthetic division later, okay?
So, yeah. So, x, because x times x is x squared.
Very good. Write that down.
Then, then you multiply the x by 4, so it's 4x.
Very good.
So it's just going to be 1x, or x.
Good.
So let's just put 1x plus 4. Okay, so I would say you should put 1
Good.
plus 1. It's a 1x, yeah.
Good deal.
It's going to be x. And then after that, 1 times 4 is 4.
Done.
So you get 0.
So then your factor is x plus 1.
X plus 1 times x plus 4.
Good job, man. You're getting it, dude.
X times x squared. X times 4, yep, 4x.
Yeah, if we test it, let's
After
do the
that,
box
x-
method.
one-
Very good.
Yeah, then 1 times xx.
I love how you went directly to testing to see if it worked. Very good.
Yeah, so x squared, 4x, 1x, 4. So let's see.
You did it.
Yep, x squared, yep, 4x, yep. Checks out.
Send us some gifts, you guys. We're humble.
So let's try one not with both addition but one subtraction. Let's see how we do the division on that.
Okay.
I hope the audience isn't creeping out Mr. Adam Smasher.
No, they probably are. So let's try. Let me try. Try that one. So what I love about this is I like to crash course the other topics that I find to be like filler. I'll teach those later as we go along within the lesson.
Yeah.
You tell me where to go with this.
So for negative, because it could be so 1, 2, 3, 4, 6, 12.
Good. And that was just one.
Let's try 12. But since it's negative, the root is going to be positive, but it's going to be x minus 12, I believe, right?
Right, but if you had x, you saying it's the monomial is like x minus 12 or x plus 12? It wouldn't matter though, because if your highest is 12, you couldn't have anything. You wouldn't have anything here. That's right.
Then 12 is not a good idea.
Right.
Well, and yeah, that also it's a subtraction, so yeah, there's also that too. Try 12.
Maybe try
Since for
a smaller number. Typically, I like to pick a small.
well, you say, yeah. I mean,
the only way it would be 12 would be if it was something like that. You know what I mean? Which it's not, right? Because you have that C term. So, what number?
4.
Okay, x equals 4 or x plus 4?
X plus 4.
Okay, so then that means x equals minus 4. So you have to guess the minus. So then you're saying x plus 4 for the monomial? Got it. So let's do it. I always test my work. That's how you put everything together appropriately. Because we're looking for our quotient, or the other monomial, right? So if we're looking for the other monomial, we expect it to be some sort of x minus a number. You might even say x minus the root that we're looking for. Anyway, let's go ahead and do it. You lead the way.
X.
Got it. And then,
Yeah, you multiply by 4 to be plus 4x.
very good.
So it's going to be 5x.
Wait a minute.
And then you bring the...
Getting ahead of yourself.
Yeah. Oh, no, never mind. It's going to be negative x. No. It's going to be 3x, right?
Negative 3x. That becomes a negative 4x. Remember, the negative, you want that to cancel. So whatever it does to the other number is just conventionally. That's why it's so important that we distribute this every time, because to the other number, right? That's what changes, right? Here's the change. Right? Does that make sense? Here's your change left over, son. Right? Does that make sense? So now it's a negative 3x. Good job. Now what do I do over here? Drop or die, Cage. What goes there? I'm kind of showing you here. Drop the minus 12, right? Can you hear me?
Yeah.
Okay. Are you with me?
Yeah, I'm with you. So, well, since you want to bring a negative 3, so it's going to have to be minus 3.
Very good. Oh, you were thinking. Very good.
So, yeah.
Ah, see, you're on it. See, you get it. You get it. You get it. You knew that had to be the opposite. Same thing with the other numbers. So now you do negative 3 times 4. That gives you a minus 12 here. And it
12.
fixes itself, right? So that becomes positive 12.
Yeah.
And positive 12 minus the black 12 gives you 0. Guess what? You just found that root right there. It was x minus 3. X equals 3,
So
I
it's
should
going to be
say.
x plus 4 times.
Yep. Done. Now let me show you something.
We picked...
Go
Can I
ahead.
say something really quickly? With
Yeah.
all of our guesses, we got them on the first try.
You want to get one that's not?
No,
Yeah?
but I noticed that all of our guesses were on the first try.
Yeah, it often happens that way. That's why I love this method. Remember when I was in college algebra, I was like, oh. It's like, why didn't they teach me this at the beginning? You know what I mean? When it came to factoring, it would be so much easier.
So,
Light bulb just kept going off, and I was like, why are they teaching this backwards?
how do you know, like, I mean, of course I know that you're a math teacher, but how do you know, like, what number to pick first?
I usually what I do is I usually I use a little bit of factoring knowledge, and this is now I'm not a huge number file, but anytime I have the Elon Musk number file powers, right, I let them converge with my I'll say mediocre version of Einstein Schrodinger powers, right? I'm like, okay, I can guess a few numbers here. Let's try let's guess towards the center of these guesses, right? Maybe it's even 1. I'm going to guess the center first, and then I'm going to go outward logically. So I kind of use logic. I'm like, okay, I see a positive x, I see a negative 12. I know that when I reverse foil this, I need one more than the other to be positive x. So I guess...
Not even that one more than the other.
Well, I know that when I factor this, that it's going to look like that. Because if we use the AC method, right, this is where I like, you see, my mind, remember what we learned in psychology that you got 100 in, college psychology, by the way, that the brain doesn't just focus on one region of thought. We know that now, don't we? Because what's that called? Parallel processing, right? Or dual processing. So I'm kind of seeing the groupings as I'm going through my guesses. I'm kind of using both AC, like in the background in my subconscious, right? My parallel processing, I mean. But I'm sequentially doing the algorithm on long division here in my guesses. I'm like, well, I bet you it's like x equals minus 4 then for one of the roots. So x plus 4. I bet x plus 4 is one of them. I don't need to know the other one. Even if I didn't know it, if I only knew one of the factors, I'd be like, I'm going to go with a higher center guess. I'm going to go for x plus 4. It's really just a massive guessing. Like, it's kind of like a little bit of insight mixed with a little bit of intuition. But if I did this, and I did my factor tree, well then right off the bat, I would know that I have 4x minus 3x equals that center term, right? And I'm guessing to myself, oh, you see what I'm saying? Sometimes it even works with cubics. You can guess one of those just by looking at that last term and guessing towards the center of its factors. That's the beauty of it. So what happens if I had guessed an x equals 3? So my monomial x minus 3. Let's try that. Let me do that one for us. May I? So this is what I have. This is my guess. This is what I guess is going on. Now I'm going to do it. My turn, right? Are you ready? Are you ready? Need to multiply that too. That becomes a positive 3x. I already know that other than 0. That's a 4x. I drop this. I repeat. I need this to be a 4x, so my guess needs to be a 4. So then the other one, 12 minus 12 is 0. So you're really narrowing down, you're narrowing down your guesses because you know that 2 out of the list is going to be one of them. So if you think about the Venn diagram, if you get like, if there are like 1, 2, 3, 4, 5.
It's basically, you know what this means? This means that out of the guesses that we have, 2 of them can actually be the answer.
That's right.
But we just have to find one.
Right. So even though there's 6 guesses, you only need to guess 3. Like one of them, like you only have, there's only 3 possibilities. That means at maximum, if you did this 3 times, you would eventually get 1.
Mm-hmm.
And the faster you get, the faster that's factored.
Wow.
Now,
keep this on the board because it'll help me with my guesses.
I will. Now, if let's look at something called synthetic division. I don't want to overload you. I might do synthetic division another day. Actually, we're kind of going over time.
Yeah.
We're almost in 2 hours today. But the idea with synthetic division, I do want to show you how fast it goes. So in synthetic division, we actually put it in root form, which is awesome. So if I think it's plus 4, then one of the roots is this. And you always go off of this. You put the coefficients down here. So I got a 1, I got a 1 for B, and a negative 12 here. And you know you're 1 power less. If you get a 0 down here at the end, you're done. So you drop the 1. You multiply. You do it again. Guess what? I know it's 1 power less. And if that's in root form, I take it back to its monomial form. Look how fast synthetic division is. Now, I just wanted to show you how fast this gets whenever you learn the synthetic version. It's awesome. Right now, let's stick to long division. That's still fast, right? I can't wait to show you this, but it might be a day after tomorrow. It might not be tomorrow, but I'll teach you sooner or later because synthetic division is like the king. It is the emperor. If long division is the king, then synthetic division is Anakin Skywalker. Yeah, don't get ahead of yourself. I just wanted to kind of give you some excitement so that you know how fast this goes, how fast factoring can truly be. or become. You did great today, by the way. So round of applause for Salahuddin. Salahuddin. Very proud of you, man. Very proud of you. I'm a star pupil, you and your brother.
And also, and also, since I mastered, now since now I can factor. Now the P thing, which you were showing me earlier, that's what this is, right?
Yeah, we usually use it. P can be anything, right? But it's always the polynomial that we start out with, right? So the algorithm goes like this. If you've got a polynomial, P of x, then one of these guesses, call it root 1, is going to give you the other root, right? Or whatever this quadratic is, right? You might end up with a quadratic if it's cubic. Say I had x squared plus 2x plus 1 as my answer. Let's say I had some sort of thing over here. Let's say I had like x plus 3 or something. I'm going in reverse, by the way. So let me do that real quick, right? Because it can be fun. It can be f of x. It doesn't matter, right? It's just letters. It really doesn't matter. You know what I mean? It just stands that you've got a polynomial divided by some rational root is equal to your quotient. Because remember earlier, you had your dividend, you had your divisor earlier in life, and then you had your quotient when you learned this, right? We're just using almost the same notation, right? When it, like, you would have had, like, maybe, I know that 6 divided by 2 is equal to 3, right? Then I know that it's factor. 2 times 3 is 6. I use the algorithm. Remainder 0, then I know that these are the factors. So do you see how the logic with like basic numbers is the same? We're just, you know what I mean? That's the beauty of this. You did great today. Good job. I don't know if Ham the Man was watching, but I hope he went ham on it.
He wasn't watching today, no.
Well, you did very good then.
Thank you.
I thought your brother was helping you over there. I didn't know. You're doing. I'm just kidding. You did very good. You did very good.
Thank you. Thank you.
You're welcome, man. You're very welcome.
Thank you. Bye-bye.
Bye, bub.
Bye.
Coming! Let me in! Coming! Come on! Kill me! I'm here! I'm going down! Coming! Ninja vanish!